I always want to know how to send REST requests via C code, via pure C code. And to do that, I found, and I just closed it, wait, where is it? Here. I found that there's the libcurl library, application, whatever that is. You probably know curl, the command line utility, which you can use to access or to send REST requests, to download things from the internet. And yeah, it's basically a library to transfer or to execute HTTP requests. So aside from that bash utility, which you can pretty much use in any command line, for example here it's already pre-installed in my case. Aside from that, there's also a library, libcurl, that is a, well, interface for C, for the C language. And let's see if we can use it in our own software to generate REST requests via C code. Yeah, so let's have a look. Compiling the program, your compiler needs to know where the libcurl headers are located. For some reason, when I execute that, it does not print out anything, which is interesting. When having compiled the program, you need to link your object files to create a single executable. That is clear. For that to succeed, you need to link with libcurl. And yeah, we're just going to pass this C flags and libs. Yeah. So to generate a program that sends requests, let me just create a new file. We will include standard.io. And then we will also include libcurl. Is it imported like that, or is it curl? Let's have a look at an example. It's curl/curl.h. curl/curl.h. Oh, that seems to work. So let's set up a main method and print something out. Welcome to the ultimate C HTTP application. And by the way, what's the point of all of that? If you know how to send HTTP requests from a C application, you can do anything. You can create multiplayer games. You can create viruses that communicate over networks. You can create chat bots. You can create cryptocurrencies that synchronize with each other all over HTTP. And yeah, your opportunities are endless. The possibilities are endless. So that's why I think knowing about this and checking it out is quite important. So we are printing something. So let's just check out here how we can compile that. So I would say we are going to call cc or gcc. It shouldn't make a difference. Then we're going to pass curl.c. Output is going to be curl. Just curl. That won't. Oh, does it compile? It did compile. I expected it to not compile. Maybe it did compile because we haven't referenced any curl library functions yet. So let's include the first library function. First of all, the program must initialize some of the libcurl functionality globally. That means it should be done exactly once, no matter how many times you intend to use the library. Once for your program's entire lifetime. This is done using curl global init. So let's do that. Curl global init. And it takes one parameter, which is a bit pattern that tells libcurl what to initialize. Using curl global all makes it initialize all known internal submodules and might be a good default options. So there's curl global win32, curl global SSL. Let's just initialize all. And see if that compiles. Not snake. Wait, I'm in the wrong pane. I compiled here. Okay, now the compilation doesn't work because now we have to include the libraries. And to do that, we can use curl. What did we use? What did the documentation say? Curl config, libs, and cflags. Curl config -- libs -- cflags. Let's compile, and that worked. So the execution worked as well, and the initialization seemed to be okay. I don't know if there's a return value of that function, but yeah, looks good so far. Handle the easy libcurl. To use the easy interface, you must first create yourself an easy handle. Okay, there seems to be an easy easy interface and a hard interface. Curl easy init. Let's get the easy init, the easy handle. I want it to be easy. Handle. That is a handle. So what data type is that handle? Let's have a look. That's a pointer to curl. That must be some data structure, right? Curl handle. Okay. So let me compile that and see if it works. And it did work. Then curl easy setup. One of the most basic properties to set in the handle is the URL. To set your preferred URL to transfer with curl opt URL in a manner similar to this right here. So let's just copy that and see what we can do with that. Curl easy set opt handle curl opt URL, and then we're setting a URL. And now which URL do we use to communicate with? I've already did a bit of research for a REST API that we can use for testing, and there seems to be a good one that is called http-bin.org. Let me just make this a bit bigger. And this is an online service that accepts HTTP requests and provides responses. You can also host it locally. And we can use this to just see if our application is working. So we can check out the HTTP methods. Then we can have a look at, well, wait, We can have a look at the GET request, and we receive a response from that GET request. We can try it out online, execute it, and we get and the test request is even done using curl, as you can see. And we request from this URL right here, and we get a response that is this one. So maybe that's a good first request. We probably can just set that URL here. I don't know if we should already include the get endpoint here, but let's just continue like that. And let's have a look at what to do next. Let's assume for a while that you want to receive data as the URL identifies a remote resource you want to get here. Let's assume for a while that you want to receive data as the URL identifies a remote resource you want to get here. Since you write a sort of application that needs this transfer, I assume that you would like to get the data passed to you directly instead of simply getting it passed to standard out. Yes, but why would it go to standard out? So you write your own function that matches this prototype. Okay. Then you tell libcurl to pass all data to this function by issuing a function similar to this. Aha, okay. So we can set up our own function that processes the received data, and we set this function using a function pointer right here that then points to this endpoint, to the right data endpoint. This is pretty much like a callback, and you can control what data your callback function gets in the fourth argument by setting another property, internal struct. Write data internal struct. What is internal struct? Well, you know what? How about we just execute the request and we just assume that everything else is just complication from there on. I will just execute that request right here. And if that prints out a result to standard out, then I'm already happy because I have executed the request. And usually from my C binary, I just want to transfer data somewhere. So I can just set up the target URL and then execute the request. So we execute this. We use this curl easy perform right here, and we receive as response curl code, which is the response code. Yeah, it is the response. And it can be curl EOK. Non-zero means an error occurred. So let's just check. Curl. No, sorry, what was it again? Curl code. Curl code. Success. And if success, let's call it response. And let's make it explicit here. If response equals 0, then print f success, new line, and else we print f failed request. Failed request, and we also print the code. And I assume that is an integer type. So let's just pass the response here. And I think that should be good. Let's just go to the other terminal and execute that. Yeah, great, awesome. And we have sent a request to host http://bin.org, and the final URL is get. As you can see, the curl library already did a lot of work for us. It assembled headers, it assembled the host, it created a trace ID, Amazon trace. Is that the, wait, what is that? Is that the, I think that is already the response. What is origin? Is that my IP? No idea. But it seems that the request worked, and I'm quite happy with that already. So let's see what the response body on this example page looks like. Here there are much more fields actually. But this might have something to do with the maybe it has something to do with the details on how the response was sent. Right, because maybe one difference is that here we accept application JSON, and here we accept something that is not specified. Maybe that is a difference. But I'm already happy with that. So let's try to do the following. Let's try to create that write data function. And then let's try to somehow read the data we receive ourselves. I'm not sure if that or how well that will work, because that method really doesn't look simple. And write data receives a void pointer to buffer, or a buffer that is a void pointer, so some data, unspecified how that data looks. Then a size, I assume that is the size of the buffer, and size nmemb, number mem, no idea what that is, and void user p, user pointer. Let's have a look at the documentation for that method. So first of all, we set curl easy option, and then we set the write option. But it seems like curl really does a lot of the heavy lifting, because we just set options in the C code, and then somehow things magically happen. So even though this is C, it's actually doing a lot of the work. It might look complex, but it is not. So we're passing curl up write function, and then we specify the write data function up here. So the write data function, how can we design that write data function? Let's see, write function. Real size is size multiplied by nmemb. It would be very useful to just see the variable namings for those. Size t nmemb. Nmemb. Okay. This callback function gets called by libcurl as soon as there is data received that needs to be saved. For most transfers, this callback gets called many times, and each invoke delivers another chunk of data. Aha. Pointer points to the delivered data, and the size of that data is nmemb. Size is always 1. Aha. Size is always 1. So what's the point of size? Probably that callback prototype is used in many different applications within curl or in many different scenarios. So this is a generic callback, And in some cases, the size and the nmemp might vary. The data passed to this function is not null terminated, so that's why we get the size. The callback function is passed as much data as possible in all invokes, but you must not make any assumptions. It may be 1 byte, it may be thousands. The maximum amount of body data that is passed to the right callback is defined in the curl h header file. Okay, so far so good. So let's save that and let's execute what we already have. And now I would expect that nothing is printed to the console because we have now introduced that callback function. Yeah, and as you can see, oh, failed request. Why is there a failed request? Failed request code 23, curl code 23. Failed writing body, so that might have to do something with the unimplemented callback. It got failed while writing output to the destination. Curl e-write error. An error occurred when writing data to a local file, or an error was returned to libcurl from a write callback. Aha, okay. Do we have to return anything from the write callback? Yeah, so let's just return 1, just as a dummy value. I just want to see that this is executed. No. Maybe we have to properly write data. What is actually the return value of the write data? Write data, where is it? Your callback should return the number of bytes actually taken care of. If that amount differs from the amount passed to your callback function, it signals an error condition to the library. Okay, yeah. So we have to implement that method now. Let's try to do that. With my limited C skills, I'm now conjuring something up. So we have to iterate over the buffer somehow. We can probably assume that we receive characters, character C, while, or maybe for int I equals 0, I smaller than nmemp, I plus plus, and then let's just call printf C, like that, and then we return nmemp because we have iterated over all the mmps. I know probably we should really somehow check the data received and process it somehow, but I assume that this would be the equivalent of actually printing things just to stand it out. So we have this buffer, and we don't even load the C into the, or the buffer into C yet, so let's do that. Maybe we don't even need the local character, so let's just do buffer I. Invalid use of void expression. Yeah, the problem is that buffer is a void pointer, so we have to do C equals buff, maybe character pointer buffer at index I. Let's try that. We actually have a response. And we are printing this response right here. For some reason the response is now failing, and before that it looked okay. But probably the original request we did was not valid. So and I just didn't print the result properly. So let's just go to this URL right here. So I'm going to copy that. And let's just try to curl this. Did I really write a gel? Oh my god. Of course it must be get. I wrote gel. Get. The response must be get. So let's clear that and re-execute the request. And there we are. So now we have a valid request again, and we are processing it in our own write data method. Right here we could technically do something with that data received, but we're not doing that right now. I'm just printing it to the console. So is there anything else that might be interesting? I already find it quite nice that we can just send requests via C. I would also like to test a post request or something like that. Let's see, post. Let's try it out and execute. Does it have no arguments? Maybe a put request? No parameters. What is a simple request we can test? Maybe something that is a bit more useful. Weather API free. Open source weather API. Try the API here. Okay, there's our curl URL right there. So let's try that. Let's try that same request in our own curl command. So we are specifying a get request. This should be a get request, right? I think it is a get request. Let's just confirm it. Curl v1 API v1. Then it sends arguments. It must be a get request. I mean, we're not putting any data to the weather database. I want to just read data. So let's go over here and execute that. And we really get weather data. As you can see, we get relative humidity here and days. And yeah, of course, the data is not formatted, or it is formatted in JSON. But we just print it to the console as a big chunk, not big chunk, and get the weather data that way. If we want to process that and understand the weather data, probably we would have to parse it to some structure that we can understand. I think the libcurl library has something like that to do that, because in the introduction it said we can I thought it would have something like that, because there was something about structs and filling data in structs. But that is too much for the scope of this video. I find this really cool because this enables you to transfer data via C. You can just retrieve data from somewhere, you can send data from somewhere, and this is incredibly powerful. And just as a small hint, if you combine that with the global keylogger from one of the last videos, then you can capture keystroke events and you can transfer them somewhere just like that. And it won't be recognized by any antivirus, because this is a custom well, tool that you wrote yourself, and antiviruses work based on hashes of the binary. So they can't identify those custom written software. So this is really cool. If you enjoyed watching this video, then please leave a like and subscribe, and then let's check back at a different time. Bye bye.